Okay, let's go ahead and graph another quadratic equation. Let's go ahead and graph this one. P equals negative t squared minus 2t plus 4. I have that one already written down here. So let's go ahead and do this. Here's the equation, and I'm just going to substitute these numbers into it. Substituting a negative 3 in for t, that would be p equals the negative of negative 3 squared. I put parentheses around the number I'm substituting in, minus 2 times negative 3 plus 4. Working that out, negative 3 squared is 9, opposite is negative 9. Negative 2 times negative 3 is plus 6 plus 4, and that gives me 1. So I have the point negative 3, 1. So let's put that there. And I could plot that point, negative 3, 1, about right there. Okay, substituting in negative 2 and 4t, I would get, well, let me write out what I had for the last one here. Substituting the negative 3, and that was negative 9 plus 6 plus 4, and that again was 1. Now substituting the negative 2 in for t, I would get p equals the negative of negative 2 squared minus 2 times t, which is negative 2, plus 4. And if you work this out, you get, well, negative 2 squared is 4. 4, the opposite of that is negative 4. Negative 2 times negative 2 is plus 4. And I have another plus 4. And if you work this out, negative 4 plus 4 is 0, plus 4 more is 4. So I have a point at negative 2, 4. That would put me right about here. Okay. Now putting in the negative 1 in for t, that would be the negative of negative 1 squared. So I get p equals the negative of negative 1 squared minus 2 times t, which is negative 1, I'm substituting in for it, plus the 4, plus 4. And working this out, negative 1 squared is 1. The opposite of that is negative 1. Minus 2 times minus 1 is plus 2, plus the 4. And if you work this out here, you get 6 minus 1, or 5. So there's a point at negative 1, 5 units high, right there. Let's go ahead and substitute in 0. If I substitute in 0 in for t, well, 0 squared is 0, 2 times 0 is 0, plus 4 gives me 4. And substituting 1 in for t, I get p equals the negative of 1 squared minus 2 times 1 plus 4. And so 1 squared is 1, opposite is negative 1. This is minus 2 plus 4. And working that out, that's minus 3 plus 4, which is 1. Is what you'd have right there. So there's a point over here at 1, 1. That's 1 on the x-axis and 1 on the y-axis right there at 1, 1. And really that's about all the points I need. I can see that drawing the curve through this, these points, it's going to be a parabolic shape, parabola, and it's just going to continue to go down on both sides, so that would be that parabola. We'll go on to graph one more. Okay, let's go ahead and do this one. It says the amount of money spent annually for physician services in the United States from 1960 to 1995 can be approximated by the model A equals t squared over 4 minus 13t over 4 plus 15, where A is the amount spent in billions of dollars and t represents the year, and t equals 0 corresponds to the year 1960. And it says complete the following table. So I jotted that equation down. So here's that equation. A is the amount spent in billions of dollars, and t is equals 0 is year 1960. Now they want to know the amount for 1956. Well, if t equals 0 is 1960, then 1956 is 4 years before that. 1960 is year 0. 1964 is 4 years after that. 68 is 8 years after that. 1972 is 12 years after the base year of 1960. So these are the numbers we need to substitute in for t. Now, it's nice that these are the numbers because these are all multiples of 4, and in the denominator I have a 4. So substituting in the negative 4 in for t, if I do that, substituting the negative 4 right in here for t, that would be negative 4 squared over 4 minus 13 times 4 over 4. 13 times negative 4 over 4 plus 15. And if I work that out, negative 4 squared is 16 over 4 is 4. This is a negative 4 over 4 is a negative 1. Negative 1 times negative 13 is a positive 13 plus 15. And if you add these up, you get 28 plus 4 more is 32. So I have a point at negative 4, 32, which I'll plot in a little bit. 1960s, year 0. So if you substitute 0 in here, you get 0. Here 0 plus 15, so we just get 15. Okay, substituting 4 in for t, well, let's do that a second. That'd be a equals 4 squared over 4 minus 13 times 4 over 4 plus 15. If we work this out, well, that's 16 over 4, which is 4, minus 13, because 4 over 4 is 1, plus 15. Let's see, 15 minus 13 is 2, 2 plus 4 is 6. Okay, so we got a couple points. Let's go to 1968. If we plug in 8 in for t, we would get 8 squared over, I'll put parentheses around that, 8 squared over 4 minus 13 times 8 over 4 plus 15. And working this out, I would get a equals, well, this is 8 squared is 64. 64 divided by 4 is 16. 8 divided by 4 is 2. 2 times 13 is 26, and that's a minus 26 plus this 15. Well, working this out, 16 and 15 is 31. 31 minus 26 is 5. So that would be 5. Now, if I plug in the 12, watch what I end up getting here. Substituting in the 12, I get 12 squared over 4 minus 13 times 12 over 4 plus 15. Well, 12 squared is 144, and 144 divided by 4 is, let's see, I think that's, let's do that off the side here. 144 divided by 4, 4 goes in there 3 times with 2 left over, so that'd be, I get 38. 20, that'd be 12, 24, yep, 38. So that's 38. Let's see. 4 goes into the 12 3 times, so that's minus 39, then plus 15. Well, let's see, 38 minus 39 is negative 1. Negative 1 plus 15 is actually, negative 1 plus 15 is actually 14. So that's what we have, and we can actually graph this thing now. So at point negative 4, 32, let's go 10, 20, 30s here. 10, 20, 30. So there's a point at negative 4, 32. That would be up here somewhere. There's a point at 0, 15, right about here. 0 on the x, 15 on the y. There's a point at 4, 6, 4, 6, about here. There's a point at 8, 5, right here. So you can see it's bottoming out. And there's a point at 12, 15. So at 12, it's 15 units high. So what do we get? We get a graph that looks something like this here. And that should do it. That graph's just going to continue up, and that's your parabola looking shape. So we'll stop right there for this section.